Okay, now we have an application of the standard normal distribution. Okay, say we want to compute the probability that bags of peanuts weigh between 500 and 800 grams. Given that the bag weight of peanuts follows a normal distribution with a mean of 500 and a standard deviation of 180 grams. Okay, so now we want to find the probability. Okay, that of course this is a normal distribution. So to find the probability, all we have to do is to convert the normal distribution into a standard normal. So to find the probability, we need to convert both 500 grams and 800 grams to z values. Convert them to z values. Okay? Using the formula we discussed, which is z equal x minus mu over standard deviation. We have the x, okay, we calculate the z for both values, for 500 and 800 grams, okay? So now, when we have x equal 500 grams, it is z is equal 500 minus 500 over 200 over, of course, over 180, okay? And we come up with 0, okay? Now, x equal 800, it is z is 800 minus 500 over 180, which is equal 300 over 180, you get 1.67. So we have, here actually we have, you know, we're trying to find probability weight between 500 and 800. So now we convert this one to z. So now it convert to z. So we get here probability, of course, of w between 0 and 1.67. So what we do, how to calculate this one here? Of course, to calculate the value of z, okay, what we do, so between 0 and 1.67, as you can see, this is the probability, this is the area underneath the normal distribution, the standard normal distribution, okay? When mu equal 500, it is equivalent to z equal 0. When mu equal 800, it's equivalent to 1.67 z, okay? This is the area, of course. So we need to find the probability, which is the area underneath this portion of the standard normal, curve. So what we do, we go down the column, we go down the column headed by z, okay, in the table, all the way till 1.67, 1.6, and then what we do, we move horizontally to the right, all the way till 0.07. So this is what we're talking about here. Okay, this is 0 points here and here. So we move down in the column headed by z of this table all the way to 1.6. We have 1.67. And then we move horizontally to the right all the way till 0.07. Okay, this is the probability, 0.457. So probability is equal, of course, 0.45, which is equal 0.4525. Okay, 0.4525. Okay, this is the area, of course. Of course, this table is in the appendix under heading B1, the appendix B1 table. Now, when you go to the appendix of the book statistical analysis, the table B.1 has the table of the Z, which is kind of a copy of it, okay, that try to know how to use this Z table to find the probabilities, and the body of the table consists of the probabilities. Now we move to solve other examples in this lesson. Example number 2, say that the annual salaries of employees in a large firm are normally distributed with a mean of 15,000 and a standard deviation of 2,000. Part A of the question, what percent of people earn between 10,000 and 15,000? So here, the probability between 10,000, x between 10,000 and 15,000. So the first step we have to follow is to convert the x into z, because to convert, instead of working with normal distribution, we work with standard normal. So we have to, find the z score. So the z score when x equal 10,000 is equal minus 2.5. The z score when x equal 15,000, just we plug the numbers, we come up with 0. So now probability of z between minus 2.5 and 0, we look at this. This is the one we're looking at for. Of course, in the z table B.1 in the appendix, we don't have negative. So because we have the standard normal distribution has the same characteristics as a normal distribution. So one of the characteristics of the standard normal or the normal distribution is that it is symmetrical. So minus 2.5 is the same as 2.5. So we go to of course, the z table in the appendix, and we calculate the probability of z equal 2.5, because minus 2.5, we find the probability of z equal 2.5, okay? And we calculate that to be 0.4798. So this is here 0.4798. It's the same as this one here, 0.4798. So now the probability of z between minus 2.5 and 0 is 0.4798. So the percentage of people earn between 10,000 and 15,000 is 47.98%. It's 47.98%. Now, the second part, what percent of people earn between 12,000 and 17,000? So the next step is to convert, to work with the standard normal. So now convert the x into z. So let's do this. Probability of x between 12,000 and 17,000. First, we calculate the z score when x equal 12,000. We come up with minus 1.5. And then we calculate the z score when x equals 17,000. We plug the numbers and we come up with 1. So probability becomes probability of x between 12,000 and 13,000 and 17,000 is the same as probability of z between minus 1.5 and 1. So actually, we find the probability, this probability of z between minus 1.5 and 1 is the sum of the probabilities, is equal to probability of z equal 1.5 plus probability of z equal 1. Graphically, as you can see here, this is the graph. So first, we find the probability of z of z equal 1.5 from the appendix B1, of course, because the probability of z minus 1.5 is the same as the probability of z equal 1.5. We find it to be 0.4332, and the probability of z equal 1, of course, is equal 0.3413. And so we want to calculate the probability between minus 1.5 and 1. So what we do, we just add the probabilities. We add the probabilities. which we come up with 0.7745, and the percentage of people, who earn between 12,000 and 17,000 is going to be equal 77, of course. Here we say percentage is equal 77.45%. Okay, this is the percentage of people who earn between 12,000 and 17,000. Now, the last part of problem 2 is, of course, we need to calculate the probability of x greater than 19,000. Of course, we first find the z, we convert the normal into the standard normal. So we calculate the z of x equal 19,000, we come up with 2. So now we need the probability of x greater than 19,000, which is the same, is equivalent to a probability of z greater than 2. So actually we need, if we draw the graph of the standard normal, we need this area here, probability of z greater than 2. This area here is equal 0.5, the whole thing is here, minus the probability of z equal 2. Probability of z equal 2. So probability of z greater than 2 is equal 0.5, all this area here, minus, in other words, let me write it away. Probability of z greater than 2 is equal 0.5 minus probability of z equal 2, which is equal 0.5 minus 0.4772, which is equal 0.0228. Great. Okay, so we need the probability of z greater than 2, this area. We know that the area underneath the right half of the normal curve is 0.5. So I need this one here is equal 0.5 minus, this one here. We come up with this, which is 0.0228. Okay, and the percentage is 2.28%. The percentage of this is 2.28%. The percentage of this is 2.28%. Okay, now we move to problem 3, as you can see over here. The problem 3 says the weight of cattle, the weights of cattle brought to market has a mean of 950 kilogram and a standard deviation of 150. Assume the distribution of the weights is normally distributed. Calculate the following probabilities. Probability of less than 950. A. Probability of x less than 950. So first, we convert this one to a standard normal. So we calculate the z value of the z value equivalent to x equal 950. So we come up with 0. So here, probability of z less than 0 is that we're talking about this one here. Probability of z less than 0 is equal to this one here. And the area of this is 0.5. So is equal 0.5. The area, probability of z less than 0, we're talking about this area all the way underneath this, left half of the curve is equal 0.5. Now, part B says find the probability between 950 and 1250. Between 950, x between 950 and 1250. Of course, we first find the z that's equivalent to 950 and the z equivalent to 1250. The z equivalent to x equal 950 is equal 0. And the z equivalent to x equal 1250 is equal, as you can see the calculation here, by using the z-score, is equal to 2. So now we're talking about probability of z between 0 and 2. Probability of z between 0 and 2. Okay, this will give you the, of course, the area underneath the right half of the normal curve, which is equal, we calculated from the table or Z table in the appendix, which is equal, of course, 0.4772. Probability of Z between 0 and 2, between 0 and 2 is equal 0.4772. Of course, you calculate that from the Z table, okay? And you will find the probability 0.4772, which is the area underneath the curve here in the right-hand half between 0 and 2. Now, C more than 1250, probability of more than X more than 1250, weight more than 1250. So probability of X greater than 1250, more than, which is the same as greater than. So we use of course, the inequality greater than X, probability of X greater than 1250. We calculate first the Z of X equal 1250, and we come up with 2. So now we need the probability of X greater than 2. This is 2. So we need this area here. So first, this probability is equal, probability of Z greater than 2 is equal 0.5. This 0.5. All the area from 0 all the way to here is 0.5. And I need this one here. Okay, it's equal 0.5 minus probability of Z equal 2. So probability of Z greater than 2 is equal 0.5 minus 0.4772, which is equal 0.0228. So probability of Z greater than 2 here, probability of Z greater than 2 is equal, probability is equal 0.5 minus probability of Z equal 2, which is equal 0.5 minus probability of Z equal 2. You calculate that from the the Z table in the appendix B1, and you come up with 0.4772, which is, you come up with 0.0228. Okay, this is okay. Now we continue with the solution of problem course 3. Now we move to part D. Part D, of course, it says we need to find the probability of of X, or the weight less than 850. Probability of X less than 850. Of course, we convert that to standard normal by calculating the Z score. So Z of X equal 850 is going to equal minus 0.66. So probability becomes probability of Z less than minus 0.66. We're talking about probability. This is, the normal distribution, standard normal. So this is Z over here, which is minus 0.66 over here. So we need the Z, or the area, to the left of this. Okay, this is equal. We find probability of Z less than minus 0.66 is equal 0.5. The whole area in the left half of the curve, of course, minus the probability of Z equals 0.66. Probability of Z equals 0.66 is equal 0.2422. So it's equal 0.5 minus 0.2422, we come up with 0.2578. This is the probability of Z less than minus 0.66. Now we move to part E. Part E says between 1,100 and 1,250. So it's going to be equal the probability of X between 1,100, okay, and 1,250. We first find the Z when X equal 1,100, we come up with 1. We find Z when X equal 1,250, we come up with 2. So now we convert this one to Z. So this one, probability of X between 1,100 and 1,250, becomes probability of Z between 1 and 2. And so this one, probability of z between 1 and 2, is going to equal probability of, z equal to, which gives you the area from z, from 2 all the way to 0 here. Okay, gives you all the area from 2 all the way to 0, minus the probability of z equal 1, which is the area from here to here. So we'll come up with the area between z equal 2 and z equal 1, which is equal 0.4772 minus 0.343, and we come up with 0.1342, 0.1342. Okay, so probability of z between 1 and 2 is going to equal probability of z equal 2 minus probability of z equal 1. Probability of z equal 2, it is the area between 2 and 0. Probability of z equal 1 is the area between 1 and 0. So difference between them, we come up with this. Now we go to F, between area between, or the probability between 950 kilogram and 1414 kilogram. Of course, first we convert that to z. We find the z when x equal 950, and the z when x equal 1414. We come up z x equal 950 come up with 0. Z 1414 is equal 3.09, and so the probability, of course, will come up with 0.49, almost 0.49. So probability of z between 3.09 and 0 is about 0.4990. Now we move to G, more than 1700. So G, probability of x more than 1700, we first find the z of 1700. We come up with z equal 5, and probability of z greater than 5 is 0. Why? Because this is 0 point greater than 5. It's 0. It's not, we're talking about something like this. We don't have, area for it is 0. So probability of z greater than 5 is equal to 0. Now we move to, of course, I, probability of I, and probability of H. And now probability of H is less than 17 kilogram. Less than 17 kilogram is the same thing, but it's less than 5. Less than 5, we're talking about this area here, all the way, which is equal to 1, close to 1. So probability of z less than 5 is about the whole area underneath the normal curve, which is equal about 1. Now we move to the last part of the question, which is between 800 and 1300. Probability of x between 800 and 1300. We first find the z of 800. We come up with minus 1. We find the z of 1300. We come up with 2.33. So z of x equal 1300 is equal 2.33. So we convert this one to z. So this one, probability of x between 800 and 1300, becomes probability of z between minus 1 and 2.33. This is what we get. This is the area, this one here. So this one actually, the area between minus 1 and 33 is the area, the sum of the areas. So it's going to be equal to, because the probability of z equal minus 1 is the same as the probability of z equal 1, because we have because of the the normal curve is symmetrical. So we find the probability of z equal 1, okay, and we find the probability of z equal 2.33. We add them together, and we come up with 0.8, of course, 0.8314, which is the sum of the probabilities of z equal 1 and z equal 2.33, and this is the area between them, which is the probability of x between 800 and 1300.